So Fastly's a CDN. We're, like I said, we're kind of a next generation, or that's kind of a cheesy marketing term. You probably actually use this without knowing about us. This is some of our customers. We've got Twitter on there, BBC, the British government runs through us, which is kind of cool. Although a bit scary, this is also some of our customers. I realize, actually, in retrospect, some of those are duplicated. I promise you that's me screwing up, not me trying to pad the stuff, but yes. This is going to be less video-oriented than some of the other stuff, although we will shove some video stuff in at the end. This is more about just like why we're different, why we did a CDN, and sort of just go on from there. So yeah, if I rush through stuff, I apologize. Grab me afterwards. I'm going to be at the cocktail party trying to surf my sort of whatever, sine waves or whatever. What the things, circadian rhythms, that's the one. Sine waves? Yeah, so people, when we started off, people asked us like, why did you build a CDN? Like, you've got Akamai, they're the 800-pound gorilla in the room. You've got Edgecast, you've got Limelight, Amazon's in the business. Like, why would you do this? And basically it's because we were really unhappy with the way that the CDN market was at the time. You didn't get a lot of control. Like, configuration was really crappy. Like, when you made a configuration change, it could take at best minutes, sometimes hours to do stuff. You didn't have a lot of control over your data. Like, you know, when you wanted to purge stuff, again, like minutes or hours to change stuff, which, you know, when you're dealing with a modern content site, and, you know, you didn't get a lot of visibility and you were locked into these year-long contracts, it was crappy. It was just a really crappy way of doing stuff. And it didn't really fit in with the way that we do development now. Like, yeah, sure, when we used to do a release once a week or once a month, that was fine. But now people do 10, 12, 20 releases a day. That didn't really work that well. And also the support was kind of crap. Like, every time you found out the support thing, you dreaded, you had to go through your sales rep, and then they would like try and upsell you on something. And it'd be like, no, I just want to figure out how to do this thing. Like, I don't want to have to pay for 2 hours of professional services. So we were like, enough! We will build our own. And it worked out. And this is our pop map. It's actually already out of date. Stockholm is already up. Osaka is coming up, I think, sometime soon. We're looking at Brazil. We're also looking at a bunch of other places, Taipei, Seoul, South Africa. It's actually really easy for us to bring up pops. So, like, based on market stuff, it can be really, you know, if you're looking on here and going, well, you don't have a place where I need it, come and talk to us anyway, because it's really easy for us to bring up a pop, unless there's really odd local laws. Like, Brazil is actually a real pain in the ass for various reasons. Come talk to me afterwards when I'm drinking. So, because it makes me want to drink. So why would you use Fastly? Like, this is the kind of salesy bit. When I started off, like, so when we were starting off doing, I suggested one of our slogans should be faster, cheaper, better, pick 3. Turns out that's why I should never be in marketing. But basically, we basically can make your site faster, we can lower your costs, and we can make your site more reliable. You know, we're basically trying to lower your total cost of ownership. And it's total cost of ownership is made up of multiple assets, and it's everything from like reliability to geographic distribution to control to visibility to how fast you can go and do stuff. And so really, we want it to be kind of part of that for you. We can reduce your CapEx and OpEx. By going through us, you don't have to have as many origin servers. And so therefore your CapEx is lower. And also our bandwidth costs are going to be lower than yours because we've got economies of scale, unless you're Google, in which case, but even Google uses. So, you know, that should tell you something. And so we can reduce your OpEx as well. If you're using us, we've got a really sweetheart deal with Google when it comes to egress from Google Cloud Storage. So that will lower your Google costs. Like, thank you very much, Google. And go and talk to our sales guys. They'll tell you like kind of how much you'll be saving. You don't need as much redundancy. You can have one data center and we will take care of it. Or you don't need quite as many data centers. We will reduce your bounce rate. Like, the faster your site is and the more reliable it is, the more likely people are to come back. And because of that, because of the faster page, will increase your page rank. And so that means more people will come to you. Will increase your revenue because there is a really, really well-known link between how fast your site loads and how much money people spend on it. and you can intuitively kind of grasp that. If you go to a site and you are like trying to buy something for it, and it takes 2 seconds for each page to load, you're gonna look at 4 items and then go, you know what, I'm giving up. Whereas if it loads really quickly, you're much more likely to spend time around. And because of that, people are gonna spend more time on site. So, there's that neat symmetry. We'll reduce some stuff for you, we'll increase other things. And the reason why we kind of can do this is that back in the early 90s, early 90s? That was, sort of back in the late 90s, early 2000s, really content was basically into either static content, like images, CSS, JavaScript, all that kind of stuff, or it was fully dynamic stuff, like CG, running hooky pull scripts through mod Perl or like ASP or PHP 3.0 for anybody who's like old school. And it was mostly, those two concepts were completely separate. It was either stuff was either static or it's dynamic, and never the twain shall meet. Nowadays, we have this term, we started using this term event-driven content, mostly because we needed some sort of marketing term rather than trying to explain it every time. But that's basically stuff like, content doesn't actually change that often. So you're looking at stuff like front page of a newspaper or something like that. Like, everybody's looking at the same front page. It's dynamically generated, but realistically, it's sticking around for 5 minutes or something like that. It doesn't actually change that much. Something triggers it that causes it to change. Somebody publishes a new story, stock market changes, a new event happens or something like that. You get a new mail. All that stuff is event-driven. It's not truly dynamic. So that's where we can come in. And that's actually a huge amount of your stuff. And if we can cache that for you, then you can save yourself a huge amount of, you can make your page a lot faster and you can save yourself a huge amount of bandwidth. So statically kind of stuff, we can drastically increase your cache hit ratio. Sorry, I've just realized the conversion of this from PowerPoint hasn't actually gone as well as it, so stuff is going off. With traditional static stuff, we can cache it really well for you. We use we call these commodity servers because they're built off commodity parts, but they tend to have 768 gigs of RAM. They tend to have like terabytes and terabytes of SSDs. We wrote our own file system. It seemed like a really good idea at the time. The reason why we're doing that is we don't need a regular file system. All we need to do is put cached objects down on disk. And if we can look after the file, we can look after the SSD, we can get rid of all of that overhead. The smaller the cached object is on disk, the more stuff we can stick on the SSD. And if we look after the SSD, instead of burning out after 3 months, we've got SSDs which are now 3 years old. And the advantage of using SSDs is that they go really, really fast. And I'm going to go into that a little bit kind of later on. We're really good for this kind of stuff. Like you may notice at the bottom, that's us. We're really fast. Cashpoint is like a monitoring and testing service. So also, look how smooth we are. It's like we're calm, ordered people. So then there's dynamic content. This is purely dynamic content. I think Akamai calls this DSA, dynamic site acceleration. They sell it as an add-on. I'm not trying to bag on Akamai. They're big for a reason, and they did some really, really important work. But like just using the kind of terms that they use. Dynamic content, you can't cache it. Let's say it's like the current time or something like that. You can't cache it, or somebody's like very, very personal data. You can't cache it. That's fine. We will accelerate it. And the reason why we can do that is like you can have an initial connection to one of our POP servers, which is closer to your users. The TCP, the three-way handshake that TCP does at the start will be a lot quicker because the latency between your user and our POP is going to be a lot better. And then between our POPs, we keep alive between our POPs. And we know that the best route between them, and at the other end, we will then go back to your origin servers. And again, the three-way handshake will be a lot faster between what we call our shield node and between your origin. That will be a lot faster, and also like we can try and keep alive back to you. So even when we can't cache something, we will make it faster. And for us though, instead of being an additional product that you buy and it's like an extra like line item on your bill, for us it's the worst case scenario when we can't do anything else. Like we'll try and hard as possible to cache stuff. But if we can't cache it, we will still make it faster. And that's just considered, well, in the worst case scenario, we'll do that. So I won't read the quotes from the side. So yeah, once again, like we rock. I'm not entirely sure what happened on February the 21st. Apparently everybody had a bad day. So yeah, we just like showing these graphs. They're nice. So then we go on kind of this third type of caching. And this is like what we call event-driven content. And that's stuff like API, mobile stuff. news articles, user-generated content like wikis. We actually kind of started off as part of Wikia. So if you've ever used like, you may or may not know about Wikia, but basically if you go to a game site or if you go to Wikipedia, if you're into Star Wars, or if you go to the Muppet Wiki, if you're into Muppets, and if you're not, I don't really want to know you, then you use Wikia, and Wikia, and in turn you're actually using us. And you think about a wiki, like MediaWiki is not the best written piece of software. It's great, but it's not the best written piece of software. It's really slow. And you think about it, it's very, very long tail. And if you had to do kind of traditional stuff of baking all the pages and uploading them to a CDN, then that would be terrible because you'd be uploading a lot of stuff and you don't know if it's going to get used. Like nobody's really necessarily going to look at the list of the names of every single of Luke Skywalker's lightsabers if you gave them names. I'm picking an example completely at random here. But when a wiki changes, when a new WoW wiki, when WoW wiki gets updated a lot, when a new WoW expansion comes out, then stuff changes really quickly. You can't be waiting 8 minutes, let alone 8 hours for a page to updated. E-commerce sites are obviously a really big thing. They're kind of just like content publishing sites, but when prices change and inventories change, you really need to update the page quickly. Sports score is another thing. Like they don't change for ages. Like the game the Dodgers game last night, like doesn't change for ages. But then when it does change, you really need to update quickly. So and people like that, we've got The Guardian. I always bring out The Guardian because it was my first sale, even though I'm an engineer. It was kind of weird. It was a bittersweet moment for me. I kind of felt a bit of my soul die. And Shazam and all that kind of content and stuff like that. So, and Condé Nast. And so Wired run through us, which gave me a massive geek thrill. So the features that really kind of do that, we have real-time purging. When you purge content from us, you can say, be gone. And we will be like, okay. And in 150 milliseconds worldwide, it's gone. And that's huge. We actually have 3 different ways of purging stuff. You can either purge by URL. You can purge by something we call surrogate key purging, which is when you can tag content with multiple keys. So each bit of content can have multiple keys attached to it, and each key can have multiple bits of multiple objects attached to it. So it's a really handy way of grouping stuff together. So if you've got the obvious thing is like if you've got an article on a site, you've got the page is you've got one or more pages with one or more images or assets in it. You tag them all with the same article ID. If that article needs to get updated, you purge it. All those things are gone. You can also tag it with the author. So if you're the New York Times and you find out one of your authors has been plagiarizing everything and you need to purge everything by that author, do one call and it's all gone. We do real-time logs. This would be useless. Like you caching stuff would be absolutely useless if you didn't know what was going on with it. And so we can stream logs back to you in real time. And we'll go into a bit of that later. I'm kind of skipping over stuff just in case I go over time. We have this origin shield, which is this idea that you can do multi-tiered caching. So basically, like stuff comes into one of our edge servers, and then we will reroute any cache misses back to an origin pop, which is right near as close as possible to your origin. And then that will shield all your requests. It will make sure that you only have one request ever going back to your origin. It protects you from stampeding herds. And also, like I said, it gives this much, much faster kind of response because we know the best route between all our pops. And we can keep alive between our shield pops and with your origin. So, and then we also do request collapsing. If 2 people are coming and asking for the same bit of content at the same time, we will recognize that and then collapse it down into one request. So again, just when you purge something, you don't see this massive spike in traffic, which would be, which mean you still have to keep this kind of redundant hardware around. So the benefits of that should be pretty obvious. Like your site is a lot faster. You can handle unpredictable traffic spikes. If you're you're the Boston Globe and sort of like you finally get into the World Series or something like that, then you're going to see a massive spike in traffic. If you're the Guardian newspaper and a royal baby is born, then that's going to happen as well. We also give you this real-time configurability. You can change your config and have it deployed everywhere in 2 seconds worldwide. Everything is API driven. We do have a UI on top of that, but everything is API driven because we don't know how you're going to be, how you want to configure us. If you wanted to build us into your Puppet chain or your Chef or whatever, then that's cool. If you want to rig us into something, that's absolutely fine. We want to work with you how you work, not force you to work how we do. So, and we're trying to give you total control over your content. You can send us back cache headers. You can override everything in our UI. You can actually upload edge scripting to override everything. We don't know how you use your content. So we want to give you the control to do stuff. It's also kind of proactive laziness on our part. Like, the more you can do stuff, the less we have to do, and that's really great. Especially back when we were starting off, it meant I could actually sleep and spend more time welding giant metal ears. And so we're trying to lower your CapEx. And basically, like, the way we were able to do this, like, when we started off, people were kind of, how are you going to compete against Akamai? How are you going to compete against Edgecast? How are you going to compete against Limelight? They're so much bigger, they're going to have economies of scale, you're going to be too expensive. And basically, they were all built on, you may notice the back of my thing says life's too short to use a 90 CDN. A lot of them built their network sort of back in the early 2000s when the internet was very different. It was crappy. Like, late 90s, early 2000s, things were really crappy. Now things are a lot better. And we can do stuff by building much fewer POPs at internet backbones rather than at kind of local ISPs. We can build much larger POPs. We can use SSDs. The big problem with using regular hard drives is the more space you've got, the slower the average seat time is going to be because the seat time is linear. It is linear compared to size because it just takes wider. It's a spinning bit of rust with a head moving over it, so it's going to take longer to do. With an SSD, lookup times are completely constant, so we can have much larger POPs, much larger drives, which means it's much more likely your stuff is going to be in cache. SSDs are really high cost per gigabyte, but they're really low cost per IOP. You were talking about 70,000 like IOPS per second compared to like 7 for like a really high end hard drive or something like that. So we can get a lot more performance out of our POPs. We get a lot more efficiency, and then we can pass those costs over. And that's the lower you increase cache hit ratio just means you get less traffic going back to you, which is really good. And if you think about it, like, we can increase your cache hit ratio from 90 to say 95%. It doesn't sound that impressive, but actually what we've just done is half your origin traffic back. So that means you can get rid of half your servers. And not only that, but then all that content, like serving stuff from the cache is going to be so much faster than having to go back to your origin, you running whatever, app, Rails app, whatever, PHP in the background, and then go back again. Like, we've just said that request has gone from being 500 milliseconds a second or something like that. It's gone back. We're responding to it within 20 milliseconds. So your page is going to be a lot faster. And then I've already kind of talked about Origin Shield quite a lot, so I won't. And we're trying to give you more control. Like, we should be integrated into your development stack. Like, when people think about cloud, when they think about Google Cloud Platform, when they think about AWS and stuff like that, the reason why it took off is because people can, it fits in with the way that you do stuff. It doesn't feel like this vendor that you're throwing stuff into. It feels like it's much more part of your development stack. Okay, that worked. We want it to be completely self-service. You shouldn't have to phone up and kind of get hold of professional services just to change something. When you push a configuration change, it should happen in seconds. All configurations should be versioned, so you should be able to roll back. And between those two things, it gives you a lot more power to do stuff and a lot more freedom to experiment. Like, if you made a change and it took like 5 hours to sort of propagate, and then when you finished, it was screwed up, you'd be like, oh God, that's really bad. Now we're going to make a change and wait another 5 hours for it to fix itself. And you're going to be much less likely to change things. You're going to be much more worried. It's going to feel a lot more fragile. If you can make a change, notice immediately from the real-time feedback from the analytics and the logs that something's gone wrong, and immediately either roll back or push the fix, you're much more likely to go like, okay, well, I'm going to try other stuff now. I'm going to try and play around and see what more stuff I can actually move to the edge servers. And then that's going to be more beneficial to you. So we were trying to, we really wanted to create a system in which you could do that. Like I said, all functionality is available via the API or a UI, and we've got this really powerful edge scripting based on something called Varnish Configuration Language, or VCL. VCL is basically a domain-specific language that lets you do anything with HTTP. It's really powerful. And so that's pretty. So you can do a lot more stuff. You can move a lot more content to the edge. And we've got stuff on there. We've got like edge authorization and paywall. We can do stuff based on GeoIP and geo restrictions. So if you've got content that shouldn't be shown to some people, but should be shown to other, you can do that through authorization. You can do mobile device detection. You can do shopper prioritization. It's when, if your origin server, your credit card payment server is kind of pretty loaded during the holiday period, you can sit there and go, okay, well we'll show up a warning page saying, hey, we're really sorry, your order is very important to us, you'll be able to pay soon. But then you can also look and go, oh, this person's got the VIP flag, or this person's got like $10,000 worth of stuff in their shopping basket. We're going to silently move them off to the VIP server and just like allow them to go through as well. We can do all your load balancing for you. Our CEO is very, very much against F5s. He really hates them, so he basically wanted that built in. And we can do stuff like data collection, stuff, Internet of Things stuff that's less relevant to the rendering people here, but I thought I'd mention it anyway. So, and this is kind of an example of VCL. This is a way of like having like a different edition for your content. So like if somebody's coming from international, somebody's coming from mobile and stuff, you could redirect around. It's kind of a contrived example, but it's in here for just for illustrative purposes. Like I said, content purging happens in 150 milliseconds. You can purge by URL. You have complete control over what is defined as a cache key, so you can make some stuff unique, some stuff not. So that can include, say, somebody's language, which they prefer to speak, or whether or not the URL has URL parameters or something in it. And you can purge by this surrogate key stuff that I was talking about. Sorry, I'm rushing because I'm noticing the clock's ticking down. And like I said, we want to give you more visibility. So we've got real-time logging with completely customizable logs. We give you real-time stats, we give you historical stats, and this gives you this greater confidence being able to change. And the more confidence you got, the more stuff you're going to cache. The more stuff you're caching with us, the more you owe us money, and that makes us happy. So that was a joke, but it's true. But it's also a joke. I'd probably skip through it. This is like an example, and I don't think I've probably got time to go through it. Yeah, we can cache content even if you've got tracking cookies inside your content. We can cache that. So you allow people to you can track people through the site. Normally, a tracking cookie would be unique to a user, and that means you can't. That means you can't really. That means you can't really like cache that at all. What we can do is generate the cookie at the edge and then track it back and then send it back via logs. So you can, even if you've got a site with a tracking cookie, you can still cache it. You can precisely follow video viewing, like if you're using HLS or HDS or Dash or something like that. Like each of those it's video separated into chunks, so you can fire a log event for each chunk. You can also send how many bytes we sent back versus the content length of the chunk, and say the session ID or the user ID if the user is logged in. So then if you're a large specialist video site, say for example, they're not actually a customer of ours, but they did a thing which showed that people tend to watch the first 30 seconds of a video, skip about 3 minutes in, and then skip to the end. Like you could see that through the logging. They're not actually a customer of ours, but they wrote a really interesting essay on it. And this is other stuff that we can show you from real-time tracking. So this is from the Super Bowl. We call this the Beyonce effect, or the Beyonce drop internally. So this is when you can see where all the advert breaks are. Interesting enough, during the Super Bowl, people stop being on the internet during the adverts. So we can actually tell you which adverts were most successful during the break, and then we can also tell you when Beyonce came on stage. We can also tell you that Beyonce was far, far more popular than Bruno Mars and the Red Hot Chili Peppers, like way more popular. And I suspect that's why Katy Perry was on this year. So I don't think I've got time to go into like how we're working with Google Cloud Platform, but basically we basically seamlessly integrated into them. You use us, you get lower egress costs from Google, and you get really good performance boosts. So, and Google are awesome, and they've been really great for us. And I've basically been touring the world, going and meeting all the GCP people, which is why I'm really jet lagged, caffeinated, and why I'm speaking so fast. So, I think basically I'm out of time. So, if you've got any more questions, come grab me afterwards, or talk to me at the event afterwards. But